Hi everyone, welcome to the session Azure Integration Services Realized, presented by Bec Lyons. Bec Lyons is speaking for the first time at Integrate. You might have already listened to her in the keynote today. In her session today, Bec Lyons speaks about end-to-end patterns and practices for integration, featuring Azure Integration Services and the wider application platform services. All the way from Melbourne, Australia, please welcome Bec Lyons.
Hey everyone, thanks for the introduction. Yes, my name is Bec and I'm a program manager on the Logic Apps team. Before joining the Logic Apps team, I was helping organizations across Australia put together end-to-end solutions with the Azure Integration Services platform. I can't express how much of a pleasure it is to be able to present to you today at Integrate, right after John's awesome keynote to show off some of our latest capabilities when it comes to end-to-end application and integration development with Azure. So to set the scene for my talk today, the world of integration is changing. Traditionally, integration meant hooking up system A and system B as an afterthought to our monolithic application development phases. However, in today's world of microservices and globally distributed apps, we can no longer rely on traditional means for integration to facilitate the scale, speed of delivery, and flexibility we need in our end-to-end systems. Integrating patterns and practices with queues, APIs, and orchestrations build in reliability and scalability to applications. So when organizations are building new systems from scratch, integration needs to be built, planned, and deployed as one cohesive end-to-end solution. So today I'm going to showcase how to build an end-to-end solution in a large-scale, distributed, multi-cloud, multidisciplined world. On the agenda today, I'm going to be walking through a recap of our Azure Integration Services and the patterns and use cases of when to use what service and when. Then I'll be talking about our new Azure Arc capabilities to talk through how you can now run and scale your integrations everywhere. And then I'm going to make this real with an example implementation of a popular solution architecture, the Digital Integration Hub. I'll walk through what the solution is and its benefits, and then take you through a sample we've published that you can take with you after this session and use it to create integrations of your own. So let's kick off with a recap of our integration services. Now, I'm sure you'll see the slide a lot circulating across the Integrate conference, but it's always worthwhile to touch upon and start a session going through what modern integration is and what the Azure Integration Services Suite is. So typically, when you distill down modern integration to its core requirements and mechanisms, you need APIs, events, messages, workflows and orchestration, ETL and batch type processing or ELT, and code. The Azure Integration Services Suite are designed specifically to cater to these integration protocols. So for all things APIs, we have Azure API Management to design, publish, and manage your APIs. For raising and delivering events, we have Azure Event Grid and Service Bus for handling enterprise messaging. For all things ETL, ELT, and big data batch processing, you've got Data Factory. Azure Functions for serverless code execution, and last but certainly not least, for all things workflow and application orchestration, not only in your integrations, but in your application systems. So the benefit of all these services is that they're all individually deployable, scalable, and pay-as-you-go, which means the kind of integration patterns and solutions you can build are really only limited by your imagination and what you need to do in your organization. So we design each of our services to tailor to specific integration needs. So it's important before you start to build end-to-end solutions that you consider what your needs are before you start to build. So let's talk about some of the decision points that a typical integrator will make when building end-to-end solutions. When it comes to implementing your business logic, a common decision point is, do I want code or low code, no code? With Azure Functions, you get the flexibility to write serverless code in the language of your choice. You can pull in your common libraries and develop and test in a way that your developers might be most comfortable. With Logic Apps, you needn't reinvent the wheel. The connector ecosystem takes care of the heavy lifting in terms of developing integrations with your systems of record, meaning you can simply drag and drop your implementation logic with our first-class designer. But it doesn't have to be an either or discussion in this case. At the end of the day, your developers are rock stars. So where you need to write code that is specific to a business, be super productive with Azure Functions. For everything else, you can save time on development and management and maintenance of those connectors and integrations by utilizing logic apps. Now, I mentioned earlier that the true power comes in when we build our applications and integrations with integrations in mind and integrations built in. Now, with the new Logic Apps standards queue, this actually runs on the Azure Function runtime, which means you can now develop your application code with Azure Functions and your integrations with Logic Apps side by side in the same code developer, and the integrations and synergies between them has never been better. So stay tuned for the demo where I showcase running Logic Apps and Azure Functions side by side. So now that you've decided that you're going to implement your implementation logic, however you're going to do it, let's talk orchestration. Orchestration is essentially how you get information from one system to another, including processing, mapping, enhancing, and transforming. For Azure Integration Services, the engine that underpins all these orchestration options is Azure Logic Apps, which provides the backbone for Azure Data Factory, Azure Logic Apps, and Power Automate. While it all runs on the same engine and we use as a shared connector ecosystem, each service is tailored for a specific integration scenario. So for Azure Data Factory, this is great for large data processing and all things ETL, ELT, and big data. An example usage here would be taking a bunch of data from a source, such as SQL Server, to a sink, for example, Azure Cosmos, and applying machine learning, AI, various ETL processes through a rich data pipeline. For Logic Apps, this is great for integrations, reacting to events, processing and transforming information, and passing it along to our downstream applications. An example of this would be, for example, taking a message off a queue, processing it and mapping it, and then updating various dependent systems of record, including SAP, your web apps, APIs, or something like SharePoint. Power Automate is designed for the power user who wants to automate their own tasks or processes within their organization. For example, as a user, I may need to update my team site and Power Apps when something new enters my SaaS system. Now, because we share the same engine, we also share connections, which means that you don't have to choose one or the other. You can simply use the best tool for the job based on the scenarios I just went through and seamlessly integrate them together using the connector ecosystem. So let's talk about messaging and queuing. When it comes to building end-to-end solutions, both Service Bus and Event Grid are vital tools to have in your integration arsenal, particularly when it comes to building distributed applications. Queuing adds resiliency to your integrations and applications. And really, in today's modern distributed cloud-native application ecosystem, they're pretty much non-negotiable for any new application. Now, whether you choose Event Grid or Service Bus really comes down to whether you're planning on handling messages or events. Think of a message as an envelope the mailman delivers to your mailbox. The information the consumer needs to process that message is within that little paper package. An event in this scenario is a little red flag on the mailbox going up, a lightweight way of notifying a consumer that there is information ready to be processed. But it's up to the consumer to go and grab that information. So if you need things like first in, first out processing or are dealing with high value enterprise messaging, then Service Bus is your enterprise messaging platform for you. It handles messages in a push-pull pattern, facilitating both queues and topics. Now, if you're building event-driven applications or integrations where you need speed and scale as well as reliability built in, then Event Grid is absolutely awesome. It's great for reactive programming when you want to trigger logic to react to status changes. Now, in some cases, it is an either or. So, for example, if you do need first in, first out processing, then definitely something more like a messaging queue would work well. In other cases, you can take advantage of the enterprise messaging capabilities of Service Bus, but also apply the event-driven model of Event Grid. So here's an example pattern where you can use both Service Bus and Event Grid. This is a new capability. Service Bus can now emit events from event to Event Grid when there are messages in a queue or a subscription with no receivers present. You can create Event Grid subscriptions to your Service Bus namespaces, listen to these events, and then react to the events by starting a receiver. What that means is that you can now use Service Bus in reacting programming models. So this is an example of that same pattern in a pub sub end-to-end pattern, where a logic app reacts to a call from a client and pushes a message onto a queue. Rather than the second logic app here that you see on the screen, having to constantly poll that queue, which can chew up CPU and billable actions, we can actually configure our event grid to tap our logic app on the shoulder, which will kick off the workflow where the first action in this case would be for the logic app to go ahead and pick up that message off the queue itself. Now, there are many patterns leveraging queues such as pipes and filters, competing consumer, and more. To see a list of these, and if you want to see more information, head to aka.ms/AIS messaging patterns. But if you want to see a really cool session going more in depth on how to implement some of these patterns in logic apps, Derek's going to be going through this in the advanced integration session on day 3. He's going to go through claim checks, sequential convoy, and more. So stay tuned for that. So that is our integration ecosystem and where you may choose to use the services for particular patterns and scenarios. Now, you might be thinking, yeah, that's great, Bec. That's all very well and good to support my distributed applications and integrations on Azure, but I don't have everything on Azure. I have systems of record on-prem that ain't going to move anytime soon. I have systems in other clouds. How does Azure Integration Services help me integrate alongside these solutions? Well, what if I told you you can now run your integrations anywhere? The cloud, the edge, on a laptop on your desk. Well, as of last week, we are excited to announce the preview capabilities of Azure Application Services running on Kubernetes and anywhere with Azure Arc. John mentioned this in his keynote, but I'm actually going to be going through a little bit more detail on this above and beyond the demo that I showcased there as well. What this means is that you can now run your favorite integration services anywhere, including Kubernetes on Azure, on-prem, the edge, and other clouds. Any Kubernetes cluster connected through Azure Arc is now a supported deployment target for your Azure Application and Integration Services. So what this means is that you can use the integration services like you normally would. The developer and the integration specialist scenarios are the same. The design is all there in logic apps, but you can now choose to deploy it to more places and more locations. What this means is you no longer need to choose between wanting the productivity of PaaS, but having to sacrifice the control of infrastructure. Now you can get both. It's awesome because you don't have to build and maintain custom solutions for non-Azure environments. You can simply write once and truly deploy anywhere. Okay, so I've talked about Azure Arc. I've talked about our Azure Integration Services. Let's actually dive into an example end-to-end solution, which is developed with the full suite of Azure Integration Services and also showcasing how we can write solutions once and deploy anywhere. So when I talk about building end-to-end solutions, as I've mentioned earlier, it's not a case anymore of building your app and then adding on integrations and afterthought. You can do this, but you really unlock the power of the ecosystem when you design and build systems with integrations integrated in. It's a lot of integration and integrate talk at the Integrate conference. What this means is I need the ability to write code and integrations using the same development tools with end-to-end testing and debugging in tools that I know and love, so such as VS Code. I also need the ability to package up my individual components, build, test, and deploy them as one cohesive solution through Azure DevOps and GitHub pipelines. And I need a way to be able to operate this and manage this at scale as a single pane of glass. So this is where we can leverage Azure and the Azure Arc ecosystem and things like Azure Monitor and App Insights, Azure Policy, and more to get that true single pane of glass view across all of my integrations, whether they run on Azure or not. So let's jump into an example and make this real. Okay, so like any classic demo, we have Contoso. This is a very simple view of what Contoso looks like. Contoso, like many organizations, have mainframes or on-premises databases which house all of their core business data. Now, Contoso's users and staff used to work in the office on a tethered PC to be able to access their systems. Okay, so 2020 hits and everything changes. the business has had to rapidly build out new mobile front ends so that users can do their job productively from home and on the go. In this case, they rapidly developed some new front ends using Power Apps. So Contoso now has a nice and shiny front end designed and developed, and it looks great. But Contoso has a problem. They aren't allowed to expose their mainframes or their on-premises databases directly to the internet. Now, here you might be thinking, well, let's just add in some API. Problem solved. Or is it? Contoso in this case has spent millions of dollars on their mainframe and on-premises data stores. Currently, they can only handle a few thousand transactions a second, but they expect this demand on the system will grow exponentially as the amount of calling clients, in this case, the Power Apps, is expected to grow. Now, Contoso can't overload its mainframe with new calls as the whole system will go down, but it also can't hold up its staff as they need to do their work, which is critical for the business. They simply don't have the time or budget to add in more capabilities or modernize their mainframes and on-premises databases. So how does Contoso make their legacy systems available to modern clients on a device anywhere with the ability to scale beyond their traditional on-premises limitations? Well, this is where our solution, our example pattern comes in. This is a very baseline overview of a digital integration hub. The digital integration hub is a new solution architecture gaining a lot of popularity amongst organizations looking to solve similar problems like Contoso. The benefits of a digital integration and hub include the ability to provide responsive 24/7 always-on API services, which provide our modern clients, in this case, a Power App, with fast and responsive experiences. But it also provides this without overloading our backend systems of record. How it does this is through a layered architecture, as seen here, whereby the front-end API services to implement the business logic to create, read, update, and delete core business data that your client needs to interact with. Pardon me. The data store here provides more than just a cache of the recently used data. It's a managed and extremely fast and scalable representation of your backend system of record with analytics and in-memory capabilities to enable speed, observability, and discovery of data throughout your organization, combining many disparate systems of record. And finally, we've got an event-driven integration layer, which is what keeps the data store and the backend system of record in sync, doing transformations, throttling, and more. So for something like this, as we build new microservices, we need to think about the integration patterns that power this with both the API facades and the event-driven integration. So let's dive into how we would implement this with Azure Integration Services. Now, here is our take on the digital integration hub. For your front-end layers, you have API management, providing the discoverability and the gateways for all your APIs. The microservices leverage Azure functions, which provide the flexibility to be written in my developer's language of choice. The data layer in this case is leveraging PostgreSDB, and anyone who's used Postgres can appreciate the hyperscale capabilities that it provides. For analytics and getting that single pane of glass view over this data source, this is where you can optionally choose to add in something like Azure Synapse, which can help extend the solution. The integration layer in this case uses a combination of event grid for the event-driven programming model to ensure that the system responds to all API events in real time, and logic apps, leveraging the 450 plus connector ecosystem to react upon these events and natively integrate with our backend systems of record to sync data. So that's our solution. That's the slides. Let's actually dive into a demo to see how we would put this together end to end. Okay, so I've dived straight into Visual Studio Code. Now, I put a poll out in the keynote, and it looks like about 50-50 of us like VS Code and the VS environment, and the other 50% like Azure. So I'm going to try and split the time here, going through VS Code and then going through what this would look like on Portal. So what I'm showcasing here, this is actually my digital integration hub, which I'm now running locally in VS Code. It's got a couple of things in this solution, which I'll note out to you here. So I've already opened one of my workflows here, but I have a logic app here under the logic folder. And I've also got all my other ancillary pieces here. So in this case, I have an Azure function, which is implementing that CRUD-based API, allowing me to create, read, update, and delete certain items in my database. In this case, that is kind of like the microservice that is the front end to my digital integration hub. The data layer here is Postgres, and I actually have a local Postgres instance running in this particular dev container, which means I can actually get some live debugging here with some live data. So let's dive into the pieces in my integration. Now, I can actually develop out my code and my integration all in this one end-to-end environment. In this case, I have two separate workflows which actually react upon events happening from my Azure function. Behind the scenes, this is leveraging Event Grid. So my first workflow is calling the Event Grid connection, and it will simply be kicked off every time Event Grid pushes out a notification to this particular logic app. In this case, I'm going to do some conditional logic to check whether that payload has data or not. If not, I can do error handling and retry logic or send a response back to another process to do some further handling. In this case, I've just terminated the pipeline. If it does have data, in this case, I want to go ahead and invoke a child logic app. Now, this is a really cool pattern that really lights up when you use the standard SKU. With consumption, because the resource mapping was one-to-one, i.e. one logic app resource, one workflow, to call a child logic app or another logic app meant another hop to another process. With standard logic apps, the resource mapping has changed to be more aligned to Azure Functions, whereby with Azure Functions, you have multiple functions within a function app. And the same goes for logic apps. You have multiple workflows within your logic app. What this means is that I can now do things like this, where I'm decoupling my logic app trigger. In this case, it is the Event Grid trigger. I'm decoupling that with my business logic for my actual integration implementation. What this means is that this makes my workflow a lot more modular. So if one day I decide, hey, I don't want to use Event Grid anymore, I maybe need some more reliable first in, first out message processing, I can now remove this trigger, use the service bus connection, and that won't touch my backend implementation logic, which makes it really easy to test. For this is just a HTTP endpoint that I can call from any particular testing tool. And I can get really rich end-to-end debugging across all of my services. So that's a really cool pattern to note with the new Logic Apps standard runtime. Something else to call out here. Actually, spoiler alert, I'll build out my integration and then I'll do end-to-end testing with my Azure function. So now, that's right, I have another one running. Excellent. That's why you always have a backup environment ready. All right, so I'm going to demonstrate some end-to-end testing with the Azure function running, as well as my logic app running. So in this case, I have my functions, which I'm developing locally, and I have my logic apps, and I've made some new additions, and I want to go test it out. Now, I could test this logic app individually, attach a debugger, as I could with my Azure function, but I actually want to see my Azure function and everything in between for that particular solution is working end to end. So this is where I can now run end-to-end debugging with logic apps and Azure functions. So in this case, I'm going to go start my logic app. I'm going to start my function. I'm doing it via the command line because it's easier. And as you can see, I have now got that sync items endpoint working here. And you can see that CRUD-based API that is being exposed by my function. Close that. All right, so in this case, I'm just going to curl and hit that get item. Very simple, but keep an eye on the left two panes. The left-hand pane is the logic app running. The middle pane is the function running. So I'm going to hit that. And as you can see, my function's kicked off and it's also kicked off my logic app, thus showing that my end-to-end flow is working as expected. But that's not all. I can attach breakpoint debugging to my workflows. I can also do that with my functions, or I can choose to come into the overview pane and actually see that rich run history that we're used to seeing on the Azure portal. So if I come and tweak this down here, I can actually see all those successful runs that I've just been hitting. If I go here and click show run, I can actually see the data that was flowing through from my event grid to check and validate that all that's going well. And there you go. I can see my inputs. I can get my outputs. Anything that you would typically do in your run history, I can now see from here. And this is all triggered from my function, which is running locally. Pretty cool. Okay, so in this case, this is where, you know, we can continue to build more things here. My other dev environment died, so I'm not going to show that, but this is where you can call those the Azure ecosystem of connectors to actually show, you know, what to build on this integration and actually integrate it with your backend system of data, system of records. So if it's a SQL server on-prem, I can use a SQL action. If it's something like a queue on my mainframe, I can use the MQ connector. So the limitations or the possibilities are endless here, and we can leverage all of those rich connectors that we might be used to today. So that is taking off my developer hat and now looking into the second phase of that end-to-end deployment pipeline. Now we want to take this solution that we've built and we've tested locally, and we want to go push this up to our environments. So in this case, this is something that we would typically check into source control. In this case, for the demo, I'm using GitHub, but you can absolutely do everything that I'm showing today in something like Azure DevOps or your DevOps tooling of choice. In this case, what you do, you would check in your changes. I haven't made any changes here, so I'm not going to check anything in. And this would typically kick off a build process in your DevOps tooling of choice. So this is that particular repository that I was working with. As you can see, I've got the logic file and I've got my function here in my function file. Pardon me. I'm going to showcase what the build pipeline looks like. Now, this is something I ran earlier. What the build pipeline is doing in this case is it's going to build up my function, it's going to build my logic app, and it's going to apply any tests and validations to make sure that everything in that particular solution is working, it's not breaking, running similar processes that I was running locally there. And that's going to publish all that out into a build artifact. In my deploy phase, my deployment pipeline is going to take that artifact. It's going to deploy my infrastructure resources to my Azure resource group. And then it's going to deploy my applications on top of that and do any other end-to-end testing. And then we have our environment. So I ran this about an hour, 3 hours ago in this case. Time flies when you're having fun. So this is that particular resource group that pipeline deployed for me. I've deployed it earlier because some of the things here, like API can take a little bit of time. So in this case, all those different pieces of the Azure Integration Services environment, they're all running for me here in my resource group. So I can now, as promised, showcase what this looks like in the Azure Portal Designer. If you prefer to work in the designer, in the portal, you can absolutely do this. And just use those pipelines to just deploy the resources, and then you can get stuck in once it's all deployed. In this case, I can see that event trigger here. It's looking exactly the same as I had it locally. Oops. Okay, so in this case, I'm going to go ahead and test out that function so we can see that particular workload being hit. Also, just time checking. How much time do I have left? This is a lesson in always putting always on to true, as you do get a couple of seconds of cold start. But as you can see, that get response is now getting me the data from my PostgreSDB. Now, if I navigate back to my Logic app, I'll be able to see the successful runs of that particular workflow. So if we dive into the trigger and have a look at my previous runs, there we go. We can see that that one, which is currently 10:41 my time, has successfully run. If we can go dive into the run history, we can see that data flowing through the particular branch, which goes and triggers my child Logic app. It's super quick, as you can see, because it's all running in the same process. Well, we've also done that deployment pipeline has also deployed that API facade to my API management. So if I go drill into the API management that was created from that pipeline, this has automatically uploaded it. I can now dev and test it here. And I can also house all of my different APIs for all my different digital integration hub solutions and use this as a single pane of glass to discover all those APIs and endpoints that I can use as a developer to build my clients. So as you can see, I've got that items API. It's pointing to my functions backend. If I go ahead and test this here or in the developer portal itself, I can get that really rich view of that particular API. Here, I'm going to send that. It's going to do the exact same thing as calling that function. But now I can actually apply different policy and throttling limits if I need to. Okay, we'll let that one load. In this case, we want to talk about how we can extend that. So we've deployed our solution, our end-to-end solution to Azure. But how do we deploy it to more locations? You know, as I mentioned before, you might not have all of your different resources running in an Azure environment. You might have things running on-prem. You might have things running in other clouds. What if I want to deploy this exact same solution, but to different environments? Well, the release pipeline that I mentioned earlier, not only did that deploy my infrastructure as code resources defined in Bicep to my Azure environment, it also deployed it to my Arc-enabled Kubernetes cluster. So if I go to that resource group, you're going to see that things look and smell the same. You know, I've still got my APIM, I've still got my Logic app and my Azure function. But if I go drill in here, I can actually see the endpoint looks a little bit different to my normal Azure.websites endpoint. Let that load. I think it's my internet, which is causing some grief here today. There we go. All right. So as you can see, this endpoint of the actual Logic app itself looks very different to the one we deployed before, which was azurewebsites.net. This is running on something called Bec Test Central. Now, you might be asking yourself, what is Bec Test Central? Bec Test Central is my custom location running on a Kubernetes cluster. We go. So this is our resource group, which houses Bec Test Central. Bec Test Central is a Kubernetes cluster that is not running on Azure. It has been Arc enabled, as you can see, using this Azure Arc resource. What that Azure Arc enablement does is essentially it visualizes that Kubernetes cluster to the Azure runtime so that it can actually do management and things like that on top of it. I've then got a log analyst workspace. But I've also got this Kube environment, which is actually running the Azure application platform services, but on that Kubernetes cluster. And I'm visualizing or showcasing or advertising that particular location as a custom location so that as a developer, I develop my Logic app the same and functions the same, but I now deploy to a custom location, which in this case is Bec Test Central. So my workflows don't change, my Bicep files don't change, and it's just pointing at a different endpoint, which enables us to write once and truly run anywhere. Now, I can go on about this for days, but I'm wary of time, so I'm going to flick back into the slides. So you might be asking, like, that's great, Bec, but how do I actually go and do that? Where do I start? Well, we actually have a Azure sample, which you can take that solution that I just showcased in terms of building that API with functions and Postgres and integrating that solution with Event Grid and Logic Apps. All you need to do is use it as a template and clone it, and you're good to go. It'll implement all that functionality for you. You can build it and have it running on Azure within a matter of minutes, helping you to get started quicker with end-to-end solutions on Azure. I will just do a quick time check to make sure that I'm all running on time. Oops.
We have like 9 minutes more.
9 minutes? Excellent. All right. Well, in that case, I do have time for that second demo. Okay, so this is the Azure sample that I mentioned. It's the exact same application code that I was showcasing before. If you want to go ahead and use this, all you have to do is head to the Azure samples repo, click use this as a template, put it into your own organization, give it a name. I'm going to give this name of integrate demo. Give it a description, put it as public or private, whether you want to share this out with the world. And then once that goes in pools, all I need to do now to get that running on Azure is just trigger that build. It's going to build up my resource group and deploy all those different resources. It's going to build that application and publish it out for you. And then you're good to go and start building your implementation logic on top of the function or on top of that logic app that we've provided for you. So a quick recap of everything that I went through. So Azure Integration Services provide flexibility in terms of tools, how you run them, and now where you run them. You can leverage Azure Arc to build your solutions once and deploy them to all the environments that you need to run your integrations, whether that be on Azure, off Azure, on an IoT device, wherever you can run an Arc-enabled Kubernetes cluster. If you want to get started with an end-to-end solution like the Digital Integration Hub, you can now clone that sample and build on top of it. We are interested in building more of these end-to-end solutions. We want to make the end-to-end experience for building integrations with the Azure Integration Services as seamless as possible. So if you do have feedback, we'd love to hear about it. Please send any questions or feedback you have to the particular server that I have there. It's aka.ms/integrations-samples-feedback. And we'd love to hear what samples or end-to-end integrations you'd love to see implemented as an Azure sample. So now we have time for questions. I'm going to flick over to the Q&A portion. If there's any to be read out loud, I'm ready to answer.
I have accepted all the questions and it is there in the accepted tab. You can go through one by one, or do you want me to read out the questions?
Let's go read them out. So the standard workflows, is it possible to set how long the workflow run history will be preserved? So the run history is now actually kept in a separate data store, whereas before it was abstracted away from you in the consumption layer. In standard, it's all in your Azure storage account. So you define how often or how you'd like to back that up or retain it. Can I get my hands on the build deploy YAML files used here by Bec? Absolutely, yes, you can. I have the Digital Integration Hub solution there, ready for you to get started with. Is GitHub how we plan to share these particular just waiting for these to come through. There was a question that was GitHub where we plan to share these samples. Yes, for now, but we'll be working towards getting similar samples and solutions with Azure DevOps if that is the tooling of choice. Another question is, how can I convert consumption logic apps to standard? We are behind the scenes working on migration tools and guidance so that if you do wish to move your consumption logic apps to standard, you will have the ability to do so. Another question is it possible to deploy logic apps and Azure functions in the same app service plan? For now, no. You have a separate plan for your logic apps and a separate plan for your functions. The logic app plan is referred to as a workflow standard plan, and the Azure function plan is your typical Elastic plans that you might be using today, whether that be premium or consumption. Is there a way to authorize API connections through the ARM templates? Yes, if you go and dive into my particular sample, the event grid trigger that you saw there, that actually uses a service principal. So I'm passing through a service principal as part of my GitHub secrets, which is a great way to injecting things that need to be kept secure. There's a whole bunch of ways that you can do that. I think really what the question's really asking is there a way to automatically authenticate against those OAuth-based connectors, so such as Office 365 and SharePoint? For now, you still need to authenticate those manually via your means that you're doing that today. However, there are ways around this. For example, you can implement a pattern where you deploy all of your connections to a connection resource group and all your logic app and integration infrastructure pieces to another resource group. What this means is that you can deploy your applications, your logic app infrastructure at a faster cadence and don't really touch your connections and only really redeploy your connections when you need to, because it's only when you redeploy those connections do you have to re-authenticate. So separating them out into two separate resource groups is a really great pattern to reduce the amount of manual sign-ons that you have to do. Another question here, what about leveraging/using the deployment center capability for logic apps? Yes, so that is on our roadmap. We are implementing that. You can actually use it today and get a sample using the Azure Functions GitHub Actions. It does work, but we are implementing our own Azure Functions actions and bespoke pipelines from the deployment center. So yes, that is definitely coming. I'm very excited about it. In Azure's Service Bus, there is no event called message received. Is this on the roadmap? It depends which connection you're using. If you're using built-in connections, the actions are being built to parity with the Azure connection that you might use today. So if you don't see an action or a trigger that you are looking for, have a look at the Azure connection equivalent. And if it's something you want to see, let us know. What is the best practices to group workflows in the logic apps? Good question. I might answer it wrong because I'm not too sure what you mean, but within a logic app, you can have multiple workflows. I think it might be asking, what, like whether I have my, the consultant answer is it depends. Typically, you might want to group your workflows into a particular integration end-to-end solution. For example, for my digital integration hub, I would include all the workflows to do with syncing data between that middle layer and the backend system of record. I might have another logic app which has other workflows which might be relevant to another digital integration hub or another pattern that's doing different things in that particular case. Visual Studio Code versus Visual Studio for LA deving. So for the standard runtime, we only have support for Visual Studio Code at the moment. And for consumption, you can use both Visual Studio or Visual Studio Code with the extensions there. When can we expect SDKs for the Logic App standard? Great question. The strategic roadmap view is that we are putting more emphasis on being able to DevOps your logic apps and being able to develop against the logic app engine and runtime with more ease than traditionally. There's a whole bunch of things that we are planning as part of this to make the end-to-end development and DevOps experience richer and make sure that there's less hoops for you to jump through as part of this. So I can say it is something that we're thinking about. I don't have a particular date, but stay tuned. Does this come as a pre-configured pattern blueprint? It's not as part of an Azure blueprint, and right now the only way to deploy this is via the Azure samples repository, but this is the first step to getting it into as a first class service on the Azure portal. Run this solution, give us feedback, let us know what works, what doesn't, where you'd like us to extend it. We love feedback, so raise an issue on the GitHub repository if there's something you'd like to see improved. We're going to iterate on this, and then we'll get it as a first class pattern and blueprint. When will the tooling in Visual Studio catch up with all the extensions you've added to VS Code? You can see it's been upvoted a couple of times. So yes, that is something that we are looking into. It's not something that came out as part of general availability, but we do hear your feedback, and it is something that we are looking into. Are there pre-configured containers with Azure Application Services that can be downloaded? Great question. There are for Event Grid. For Logic Apps and Azure Functions, you can download the base Azure Functions image. If you look on our in our documentation, we have, I'll park that one for now. I probably from the top of my head wouldn't know the location of those resources, but it's something we can look into. When will Service Bus be supported in Kubernetes? I will palm that off to the Service Bus team who are presenting at Integrate. Why did Microsoft only allow the Event Grid integration with a more expensive option of Service Bus Premium only? I am not familiar with that particular use case. I would recommend asking that question. It's got a lot of upvotes when the Event Grid and Service Bus team present, but don't quote me on that. Don't tell them I sent you. How are you going for time? Do I have more time for questions?
No, Bec, we have already crossed the timing. Since it's a break, I just left for you to answer the questions. Still, people are there in the session, so they are listening your answers.
Oh, so they can hear me. Can they still hear me?
Yes, you can go and answer a few more questions here for a couple of minutes. We will give 2 more minutes.
Excellent. Just having a look at the list to see if there's any I have left.
A few more questions in the pending tab.
Yeah. So I'll address one that has come up a couple of times, and that is the migration from multi-tenant to single tenant. So I mentioned that migration tools and guidance is coming, but in a nutshell, the workflow definition stays the same. What we essentially do, what you would need to do if you wanted to manually do it, is take your workflows from, or your Logic App definition from the ARM template, which you might have originally been developing in, and put that into your workflow.json file. We have the structure of what the files look like on the documentation. The connections part, the $ connections part of that particular template, they go into the connections.json file. So we've got 2 separate files here. We separated out for modularity so that you don't have everything built into one template. It makes it easier to develop things in silos. For your parameters, they're no longer ARM template parameters, but now you can use parameterization and a separate parameters.json file. We also have documentation for that on the portal. The other thing you'll need to do is you will need to recreate your connections. The reason for this is that our connections for multi-tenant have a kind of V1, and the connections for our single tenant offering have a kind of V2. Now, there's no way to migrate those connections for now. So what you would typically do is just go into your ARM templates, change the kind from V1 to V2, and you can then redeploy them, and then they'll be used by the new Logic Apps. So that's it. Pretty much the differences. We take the original template, we modularize it out into different workflows and into the connections.json file. You can parameterize with the parameters.json file, and then you'll just need to redeploy your connections themselves so that they work within your runtime. Okay, I think that covers majority of the questions. I've kind of lost my place, so I'm happy to cut off there. But yes, if folks are interested in talking more about this, we'd love to get in touch. So send your feedback to this particular form. If there's something you want to ask, just put it in the form and I'll be reading all the answers there. So yes, we'd love to hear more feedback and hear how you go with using the Digital Integration Hub solution.
Yep. Thanks, Bec. That was a great presentation. Indeed, you have to check the chat box where people have mentioned about the presentation was good. So
awesome.
Well done. Thank you, Bec. Thanks. Thanks, everyone.
Awesome. Thank you, everyone.
Covey.co